So this is AASHTO T89 and T90 liquid limit, plastic limit of soils. So this procedure is not part of your WAQTC FOPs. This practical is a portion of your CDOT soil inspection, part of your certification. So what we're going to go through here before we begin a liquid limit test, there are several pieces about the liquid limit device that we need you to understand, that we need you to inspect, and that we need you to know how to do. So the first thing we're going to talk about is calibration of this device. So to calibrate this device, over time, we get a divot on the bottom of this cup and a divot on the base plate from the cup bouncing up and down. To calibrate this device, we need a drop height of 10 millimeters, plus or minus 0.2. And the way to calibrate it is we're going to take a piece of masking tape and we're going to place it on the bottom of the bowl such that we cut that divot exactly in half. So that point of contact should be cut in half. And then we put it on the base plate. And then we can either use our grooving tool. The thickness of this is 10 millimeters. Or we have a calibration block. And again, the thickness of this is exactly 10 millimeters. And we then take this and we stick it underneath the bowl. And we are going to slide it in until we are in contact with the tape. That's the purpose of the tape, is to stop your calibration block exactly where it needs to go in the center of that point of contact. We then are going to turn the crank, and in order to properly calibrate this device, you should hear it barely pinging, but the cup should not be lifting much at all. It should barely be visible, and that tells us we're properly calibrated. If the cup is lifting too much, or if you don't hear that ping, you then have to loosen these screws that anchor the cup onto the base plate, and then adjust to move the cup in and out with this screw in order to get that cup at just the right drop height. When we're finished calibrating, we want to remove our masking tape from the bottom of the cup because we don't want that on there during our actual liquid limit test. Other inspection points. We need to make sure that our cup has all 4 rubber feet on the bottom, and we're really concerned about the condition of this brass cup. We do not want any portion of this brass cup to be less than half of the original thickness. The divot that forms on the bottom of the brass cup should be no more than 1/2 inch in diameter. Same with the divot on this base plate. If this begins to grow larger than 1/2 inch in diameter, you need to replace the device. Secondly, during this test, we will be showing you that we're going to cut a groove into our soil sample in the center of this cup, and we do not want a pronounced groove to be developing in the base of this cup. If you can feel that groove with your fingers, it's time to replace your cup. So that's calibration, and those are the inspection points that you need to know and that you need to demonstrate on this practical exam. Now we're going to go into the test procedure itself. So, sample preparation. You are going to run material over your number 40 sieve. So this will be screened, and this is everything that passes your number 40 sieve from your original test sample. It's dry when we begin. And to combine a liquid limit test with your plastic limit test, you're going to want approximately 100 grams to begin. You'll place about 50 grams into a porcelain dish, and you'll begin to wet that material. We are going to be doing the liquid limit method B. So you need to study method B in the AASHTO procedure because that is the method that we use here at CDOT, and that's the method we want you to certify with. So do not concern yourself with method A. Let's think about method B. So we'll start with about 50 grams of material. We put it into a porcelain dish, and initially you will add 8 to 10 millimeters of water to begin hydrating that material. You will knead it, chop it, stir it to get that water incorporated. And then incrementally after that, you will add 1 to 2 millimeters of water at a time. And again, knead, chop, and stir to incorporate that moisture. Once you reach a plastic state of your material, in other words, once that material, you can begin to roll it into balls and threads, you're going to take out approximately 10 grams of material and set it aside for your plastic limit test. My assistant here put this lid on. There we go. So about a 10-gram ball, and again, you're going to want to be able to roll it into threads and balls, and that is what you're going to use for your plastic limit test, about 10 grams of material. Okay. So the liquid limit. So again, we're going to add about 1 to 2 millimeters of water at a time to get it to the proper moisture content for liquid limit. You'll want to actually be measuring that water as you add it, but again, you mix, stir, knead, chop, and get that moisture and that soil uniformly combined until you have a very nice, consistent mass of uniform moisture content. If you happen to get your material too wet, and when you run this test you determine that it's too wet, you cannot add dry material to your soil. What you must do if it is too wet is you need to dry it out. And in order to dry it out, you must sit here and continuously stir it and mix it. You cannot place this under a fan and just let it sit, nor can you just leave it out in open air and let it sit, because what will happen is you will develop a dry crust on top, and the moisture will be retained in the middle, and you will then end up with a non-uniform mass of soil with inconsistent moisture properties. The other thing I neglected to mention at the beginning of this test, if we are dealing with a very high plastic clay, and we initially add our moisture content to it and get it to the state that's plastic, we will then allow that material to hydrate in a humidifier for approximately 30 minutes so that the moisture content is well incorporated into those clay particles. So once we think we have a uniform consistency here, kind of a rule of thumb to think about is about the consistency of cake frosting or creamy peanut butter. We're then ready to begin our test. Then to run our test, we will take our soil out, enough material out, and we're going to put this in our brass cup and spread it in the cup evenly. The thing to remember for this test when you're spreading your material in your brass cup, any excess material goes back into your porcelain dish, and we do not want you to ride material up on the edges of the cup. We see many people do that, and that is incorrect. This material in your cup, it needs to sit in here in a way that is level. In other words, if this were water, how would a puddle of water sit in this cup? So we're going to get our material in our cup and spread it. And it has to be 10 millimeters thick, and again level. And in order to test that we are at 10 millimeters thick, what we do is take our knife and we're going to set it onto our soil material to the back of the cup. And we want that putty knife to be in contact with the soil and to be level. Once it's level, then we know we have a good 10 millimeter thick soil puck in here. Now we're ready to cut it with our grooving tool. So this is the grooving tool that you'll be using for certification. You have up to 6 strokes with the grooving tool to cut your groove into the soil. And the goal of this is to basically, on your final cut, is the only cut that should touch the brass in this. And what you're trying to do is expose the brass at the bottom of your soil pat and have a nice clean groove with the brass fully exposed at the bottom of your groove. We don't want to rip, we don't want to tear the sample when we're cutting in the groove. And then also, when we are placing our soil in this cup, we want to make sure that we're not trapping any air bubbles in there. So we're going to begin cutting our groove. So that's a start. I didn't feel comfortable doing this with one cut initially. You want to clean off your grooving tool between each cut. So this final cut, I feel comfortable now with my third one being the final one. Again, we want to expose and score the bottom of this brass cup so that you see a nice clean groove with the brass exposed on the full length of the groove at the bottom of the cup. Now we begin our test. So what we're going to do is rotate this handle .22 to 28 blows is what you're after, and you want that to be bouncing approximately 2 blows per second. And the goal we are trying to achieve, which I nearly did successfully, is to close approximately 1/2 inch of that groove. So this is approximately 1/2 inch, the length of this block, or the width of your putty knife is approximately 1/2 inch. So for method B, once you've successfully closed 1/2 inch of your groove, and again, we don't want the whole groove to be closed, we just want the bottom. So we no longer want to see the brass at the bottom of the cup. That is a successful groove closure. So once we have 1/2 inch for method B, we are going to scoop all of this material out, and we are going to reincorporate it into our original sample here. I should have covered this sample with a cloth to avoid any dehydration or moisture loss. We're going to remix it, put it back into the cup, create a nice level surface again, 10 millimeters thick. We're going to cut it with the grooving tool once more, and we're going to, the second time, rotate that handle, and we want to achieve a second closure of the groove of 1/2 inch within 2 blows of the first one. So this closed in about 27 blows. We still have to be within that 22 to 28 blow range. So the second time I do this, I would have to have this groove close in either 25 to 28 blows. So plus or minus 2, but not exceeding that 28 blow count. Once we get that groove to close the second time, to get your liquid limit moisture content sample, you are going to take your knife and cut the section of soil where your groove closed. And we are going to scoop this out. And we're going to put it in a tared container that we already know the weight of and seal it. We will get a wet weight on that material. And then we will oven dry it according to AASHTO T255, T265. Once we have that dry weight of that material, we will then calculate our moisture content. To get your liquid limit, you take your moisture content and you will correct it by a factor that is based on the number of blows that was required to close your groove 1/2 inch on the second attempt. So once we did this on the second attempt, you will record the number of blows. You will look up the correction value on a table in the procedure in your manual. You will take your moisture content, adjust it by that factor. It's just a simple multiplication. And your liquid limit is going to be that value rounded to a whole number. So when you are certifying and you are running this liquid limit test, we do not expect you to successfully achieve closure of the groove in that 22 to 28 blow range, but we do expect you to know that. You need to verbalize that to us. So if it closes in much fewer than 22 blows or it takes much greater than 22 blows, we just need you to tell us that, well, I would either need to dry my sample back or I would need to wet my sample and restart this test. So that's something to keep in mind. We don't expect you to be perfect, but we do expect you to at least know the material. So that concludes liquid limit.